Welcome to the second video in Azure AI series. In this series, we are exploring Azure AI Foundry with a real world example. In the last video, we learned how to set up an AI project and also built a chatbot which is capable of responding us with an SQL command based on natural language question. We also explored the problem of token consumption and why context passing can be inefficient. If you haven't watched that video yet, check out the description for the link. It will give you some foundational knowledge to better follow this video. In this video, we are going to learn how to add your custom data to Azure Search, build a RAG flow, and also query and visualize the results using Python libraries on local machine. But the question that we want to answer in this video is, can we reduce the prompt size by not passing the table context? And RAG is the answer for that. RAG is a way to integrate AI with your domain specific knowledge. So, for example, if you have your company's HR policy that you prefer not to share within an LLM model, but still want responses customized based on that policy, so RAG can be helpful there. In our scenario, instead of directly querying the LLM, we first retrieve relevant data from our knowledge base, which is Azure Search, and the data will be combined with the prompt before being sent to the LLM, allowing LLM to respond based on the context provided with the query. In Azure Search, we are going to store some queries as embeddings, which will serve as the knowledge base for all our user requests. Now let's discuss what are embeddings. For instance, if you want to store a piece of text in Azure Search, it would be first splitted into smaller chunks called tokens, and each token is then converted into embeddings, which are numerical representation of the words. You can see an example here how they look like. These embeddings are stored in Azure Search. When you ask a question, Azure AI Search is going to find the most relevant match by comparing the angle between the embeddings for your question and find the possible queries. For example, in this case, if you ask this question, maybe query 2 will be returned and maybe query 1 is also returned based on this distance. And then these queries will be sent to LLM, and based on that, LLM will respond. Now let's look at how do we convert sample queries into embeddings. So we are going to use an embedding process here, where we will take our sample queries, convert them into embedding using a text embedding model, and then the generated embeddings will be stored in Azure Search. Now don't worry about this flow. We don't have to build this flow ourselves. Azure AI Foundry is going to take care of it for us. Now we are going to build this flow by first setting up Azure Search, which will act as a knowledge base for our sample data. We will then build this complete flow on Azure AI Foundry first, and then connect it with the database on our local machine. This setup will ultimately help us reduce the prompt size and also eliminate the need of passing the table context with every user question. Now let's see things in action. As the first step, I have some sample queries that will serve as valuable knowledge for my app. These queries are structured in a way where the first part is the question followed by the corresponding SQL command. You can find all the required resources used in this video in this repo. Check the description for the link. Let's start by cloning this repo. So I'm going to open command prompt and create a directory first. I'm going to clone this repo. Cool. Now let's go back to the Azure portal, and this is where we have left off in the previous video. Now to upload the sample queries, we have to go to the data and indexes section, which is on the left hand side. Click on this new data button, and in the data sources you will get multiple options. So we have to, since we are uploading the data From our local machine, we have to select the upload files and folder. Select on that, click on upload files again. Go to the repo that you have cloned. You will find the sample queries. You can give a name to your data set. So I am giving SQL queries as the name. Click on create. Once your data is uploaded, on the right hand side, you should see the SQL queries that we have uploaded. Go back to data and indexes section. So here you should see SQL queries. So now the data is uploaded. We have to create a new index based on the data that we had uploaded. Click on new index. So here in the data sources option, you will get a couple of options. So since we have already uploaded our data in Azure AI Foundry, we are going to select that option. In the index configuration option, we have to select an Azure AI search service. So since we haven't created any AI search service as of now, we have to create a new one. Now either you can create a new resource or use an existing one and give a name to your service. I'm giving AI Search 830 as the name of my service. Good. Before you click on review and create, uh, make sure you change the pricing tier or you will be charged a lot. So choose the free one. Now click on next. Make sure your estimated cost is 0 rupees per month or $0 per month. Now let's go back and you should see the Azure Search service that you have just created. Click on add connection to add this Azure Search service. Now you should get the option of Azure Search service here. Good, you can keep the vector index default. Virtual machine, you can keep the default option. Good. Click on create vector index. Once you are done with creating the index, you can click on job details and you will see behind the scene what is happening. So you can see a machine learning job is created, which has multiple steps. Now after 15-20 minutes, this should be done. Once this is done, we will go back to our search index and search for the data that we have indexed. So go to AI search and then go to your search service that you have created, and then there's an option on the top which is search explorer. We have to use this option. So from our sample queries, I'm going to pick uh, any keyword. So let's pick rides. And when I search here, I should get some response. Awesome. So we are getting embeddings that's what we were expecting. Now let's go back to the playground and connect our chatbot with the vector index that we have just created. So scroll down, you will find an option, add your data. Click on it and you should be able to get this option of the vector index that you have just created. Once this is done, now we are good to update our prompt. So we don't need the table context anymore. We can remove it from here. Now this is our new prompt where we are saying you're an assistant that transforms natural language into valid queries. This is same as what we had before. And we are saying that the data set includes embeddings. And also we are saying that generate the SQL command based on the embeddings. Now let me add the query. Cool. We are getting the right response, and this is what we were expecting. So far, what we have built is we were able to create the index, and based on that index, we have reduced our prompt, and we are getting the response. And this response is same as what we were expecting earlier. So now the next step is to run the same code that we are running here on local machine. To do that, let me jump in onto my local machine. So I have opened my cloned repo here. Open the terminal. VS Code is not required. I just opened my project in VS Code, but it's not required. So we are going to follow some step from readme.md from the project. So yeah, so all the steps are written here, so you can just copy them one by one. First, you have to check whether the Python is available or not. Then we are going to create a virtual environment, and once that virtual environment is created for us, we are going to activate that virtual environment. Next step is we have to install Jupyter, where we are going to run our code. This takes around 5 to 10 minutes. Next is to start this Jupyter Notebook. Use this Jupyter Lab command. Go to localhost 888 to access the notebook. Now sometimes it asks for password. To reset the default password, what you can do is just interrupt it, and you can just write this command Jupyter Notebook password and give some password. Good, I have updated it. Let's go back to the Jupyter Lab again. So you can see our demo notebook add also sample queries and readme.md. This is where we have some sample code. We will come to this later. Now as the next step, install the required libraries. So we are installing PySpark library, pandas library, plotly to draw the charts, pandas to interact with the data frames, Spark for the database interactions. And after some times these libraries will be installed. Now we have to go back to our AI Foundry and click on this view code button. Make sure you click on key authentication. We are not using the Entra ID authentication for this demo. Copy this code and paste it in the notebook. You can create a new notebook. Just do a new notebook, and I'm just going to rename it to SQL Analytics. So let me just paste the code. Yes. Now you'll see that there are some keys that we need to get. Go back to the Azure AI Foundry again and click on this key authentication again. Go down and you'll find your API key. Just copy this. The next part is we also need Azure AI Search key as well. So go back to Azure AI Search. On the bottom, no, not here. You have to go to settings, and inside that you have key. Copy the primary admin key and replace it here. Also, make sure you remove this image path and encode image. This will fail your code. And by default, this chat prompt, we have to update it. The format of this chat prompt is not correct. And when you run this, it will fail because the format itself is not correct. So it's saying the bad request. And update the chat prompt. So I'm going to use the format from our demo.ivpnv file. Just copy this syntax completely. Cool, I have updated it and this time it should work. Awesome. We got the same SQL command as output that we were getting in the playground. So we are good. So now the last step is to draw the charts. So go to run demo.ivpnv file, which is responsible for drawing the chart and also querying the database. Just update these 5 parameters, your endpoint, deployment, search point, search key, and subscription key. So I'm going to replace with what we had used in SQL Analytics Notebook. And also make sure the same endpoint is updated here as well. The rest looks okay. And so you can just completely replace it. That is better. Also update the index name. Let me try running it. So if you have your setup correct, you should see the search box. If I give the query daily writes in 2024, I got the SQL. Now it's failing in this machine because I don't have Spark installed on this machine. I can show you the rest of the demo in the other machine. So here I ran the same demo notebook. If I give the query daily writes in 2024, you can see we got the response from LLM. We also got the result from database, and in the end we had drawn the chart as well. Let's say now if I update the query to daily revenue in 2024, you can see the query got updated along with the database results and the charts also. Now let's look at what we have in demo notebook. So there are three parts of this a notebook. First part is responsible for drawing the charts using Plotly library. Second part is responsible for querying the data frame. So if you are looking for this file, you can go through readme.md and check the steps how to download this file. And in the end, we have code for calling the Azure AI services. And this part is responsible for drawing the chart and the button. Let's do a quick recap on what we learned so far. We were able to set up Azure Search where we ingested sample queries in form of embeddings. We got that result as part of every prompt that we sent to LLM. We got the response in form of SQL command. Those SQL command we ran those SQL command on database, and we got the result in form of tables, and we drew the charts, and in the end returned that result to the user. So that's all for this video. Thank you.